I'm Anil Kumar, sharing with you a question from the previous test paper on differential equations. The question is, the lines x plus y equals to 0 and x plus y equals to 4 over 3 are tangent to the graph y equals to f of x, where f is antiderivative of minus x squared. Find f. So what we are given here is, when we say f is antiderivative, that means f prime x, or the derivative of this, is minus x squared, right? So from here we can find what f is, taking antiderivative of this. So we get f of x as equals to minus, and this will give us x to the power of 3 over 3, right? So that is the antiderivative of this function. You can check your result at this stage by taking the derivative of this, right? So if I take derivative, I get 3x squared, 3 and 3 cancel, right? Now this is always a general solution, so we'll write this as plus c. Now to find the value of c, we can use the conditions given to us. There are two conditions given to us in this case. One of them is x plus y equals to 0, the other is x plus y equals to 4 over 3. Now as you can see, this is a cubic function, and there could be 2 points where we could have the slope as given in these equations, right? So let's analyze the slope. So from the initial conditions, let's analyze the initial conditions. We have two of them. Let's analyze the first one, which is x plus y equals to 0, and from here if we do differentiation with respect to x, we get 1 plus dy dx equals to 0, or we get dy dx as minus 1. You could also rearrange this equation, let me do it here. If I write in terms of y, let's do it on the right side. Or the alternative could be, you could write from here y is equals to minus x, and then slope is minus 1. So that gives you the derivative, right? So to begin with, we started with minus x squared. So we can equate that to minus 1 and find the value of x. That's the whole idea. So what we will do here is, we will equate this value here. So we are given f prime x equals to minus x squared, and what we found that dy dx is minus 1, so we'll substitute this as minus 1 equals to minus x squared. Now what we get here is, we get 1 equals to x squared, and this implies that x is equals to plus minus 1, correct? Square root of 1. So the x value is plus minus 1. So we get two values of x, which is plus and minus 1. Now let us say, if x is plus 1, what is y? So in this case, the points will be, if I take x as 1, y is going to be minus 1. And if I take x as minus 1, y will be equals to plus 1. Right? So these are the 2 points on which the tangent line's condition will be met. And it makes sense, since the derivative is same, the y-intercept is different, correct? So these are parallel tangents to the same curve, right? But this is going to help us to find the value of c. So we'll substitute these points here. So let's substitute 1 and minus 1. So taking the point 1 and minus 1 on this function, we get y value is minus 1. So let's substitute minus 1 here. So this is minus 1 equals to minus x value is 1. So 1 cube over 3 plus c. Bringing it to the left side, we get 1 over 3 minus 1 equals to c. So c is this value, which is minus 2 over 3, right? That is c. So once we substitute this value in our function, we do get a general solution, the specific solution for the given equation from a general equation, right? So we get f of x as equal to minus x cubed over 3, and that is minus 2 over 3, right? So that is the solution for the given question. You could always take 1 over 3 common with a negative sign and rewrite this as equal to we can write this as, let me use a different ink again, it'll mix up with this. So minus 1 over 3, right? And then we'll write this as x cubed plus 2. So that becomes the solution of the given equation, right? And you can check that this condition is also met if you take this as your function, derivative, find the derivative and check your result. I hope that helps. I'm Anil Kumar. You can always share and subscribe my videos. Feel free to post questions and like if you like. Thank you.